about a new topic, and that's a linear regression and correlation. Let me quickly put on some heading right here. After that, I will be discussing regarding this portal. Okay, right here. So it goes that linear regression and correlation. Okay, this is a topic now that I am gonna follow up here. So right here, this particular one, and now it goes. Now basically, first of all, I'll be starting out with a very introduction, that's what it is and what it is completely used for. So okay, see, we have out a case here that professionals, basically sometimes professionals want to know that how to or more numeric values are related, right? Let's say you are having a numerical data or you are having some numerical sets. So into that case, sometimes professionals want to know that, okay, how are these numerical variables related, the numerical values, the variables which you are having, how are they completely related out, right? This is what they sometimes wanted to know. Example, let me take out. So basically there is a relationship between the grade on the second math exam a student takes. Okay, if there is basically if there is a relationship between the grade on the second math exam a student takes and the grade on the final exam, right? Is there a relationship? What does and how strong is the relationship? These are all the things which basically we need to know out. Let's say a student had given out the second math exam and a student takes out the grade, and basically what's the grade on the final exam as well. So this is what basically it's willing to know for basically wanted to know, right? Another example, I could say that your income may be determined by your education, your profession, your years of experience, and your ability, right? So the amount you pay a repair person for labor is often determined by an initial amount plus an hourly fee. Right? These are all the examples in which where can the regressions be used out, right? So basically here, these are the cases where the regression can be used. Also, in that case, the type of data described in the examples, right? The examples which I had given you right above. So type of data which I had described there was the bivariate. Was the bivariate data. We often call it as BI. Okay, we often call it as BI. So bivariate data, we often call it as BI. Okay, that's BI for the two variables. Bi means the two variables, right? So it's for the two variables only. So in reality, basically, statisticians mostly focus upon the multivariate data. So it's multivariate, and here goes the data. Fine. So the examples which I had shown you, that for the bivariate data, bi means the two, right? And basically the statisticians completely see about the multivariate data. Okay, that means having the many variables, right? So this particular linear regression and correlation topic focuses upon the studying of the simplest forms of the regressions, right? Like the linear regression with one independent variables. We'll be seeing about the data that fits in a line in 2 dimensions. We'll study about the correlation. That what is this correlation for? It basically measures that how strong the relationship is, right? So these are all the things that we will be studying up here in this particular topic, that's a linear regression and the correlation, right? Now what I'll be doing is that I'll be taking you to the very first topic that not like this, I'll be taking you to the very first topic that I am having right here, and that's the linear equations. Okay, yes, this is the topic. Okay, let's come down and start studying about this particular thing. So I would start with the writing only that linear regressions, the linear regression for two variables, the linear regression for two variables is based on a linear equation, is based on a linear equation It's based on linear equation with one independent with one independent variable. Okay. Now, the form which we are having here in the for the linear equations form that we have out here. So it's y is equal to a plus bx. Y is equal to a plus bx. Hope many of you are familiar with this particular form as well. That's y is equal to a plus bx, because we get out these things in our very younger classes, right? We have already studied about these things onto our younger classes, right? So this is about the linear equations, that linear equations for the two variables. It's okay. Okay, how come this particular has been appeared? Let me quickly remove this out. Till the time I would not speak out, like I would not deny while speaking out. Okay, yeah. So linear equations basically it's for the two variables, right? We had already seen out the formula as well right here. That how is the formula and how is that completely applied out? Okay, 1 second, right, and fine. Now, let me just come down here, get out some space for me to write out and write here. Okay. Now I will be seeing about some more things. Okay, where what are the values of a and b which I'm having here. So I could just simply write out here that where a and b are constant numbers. Okay, where a and b are the constant numbers, right? The constant numbers which we are having. So that is the a and b. Okay. Now, I could mention out here that x is the independent variable. X is the independent variable, and y is the dependent variable, right? So basically we could mention out here that x is the independent variable and y is the dependent variable, right? So basically what we do, we basically choose out that which value we need to substitute for the independent variable, and then basically we solve out the dependent variable things and things related to dependent variables, right? So in that similar case, I just mentioned out here that x is the independent variable and what's the y is the dependent variable which we are having out here, right? So when we talk about the linear regression or correlation, so in that case two terms come. That first one is the bivariate data, that is bi, and the second one is the multivariate data, that's basically for the multiple variables. Now, when we talk about the linear equations, so in that case, the linear regressions for two variables is based upon a linear equation, okay, which has on a linear equation. That particular linear equation shall have about one independent variable, right? Y is equal to a plus bx. And where a and b are basically the constant numbers which we are having here, okay. What about x? So x is the independent variable and basic and y is the dependent variable which we are having. So it completely depends that what variable you set on as dependent and what variable you set as independent, that depends on you, right? So you completely to choose out a value to substitute for the independent variable and then solve out the dependent variable, okay. Hope I am very much clear with this particular thing to you as well, right? Now what I'll be doing is that, so here I'll be stopping up this particular video and will be meeting you in a new video with some new things regarding this linear regression and the correlation. Basically we'll be continuing it, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So as we already discussed about the mean of squares and sum of the squares, all the things we are already familiar with, right? So now I'll be discussing about one of the very important topics today, and that is basically the calculation of sum of squares, and mean squares and mean square. Okay, so this is what we are going to discuss up. So we'll be seeing that how we'll be doing out the calculation for the sum of squares and even for the mean of squares. So what's the procedure that we need to follow? All those things we'll be seeing up here, right? Now, and even be denoting out some different terms as well, so as to remember out the notations and what do they actually mean. That as well I'll be doing throughout. Okay. Great. So here we have the first one, that is the K. That's the small K. So that is basically what means that out. So that is the, okay, that's not the different, it's the number. Yeah. So it is the number of, it is a number of different, it is a number of different groups. It is a number of different groups, right? So this is what is the calculation of sum of squares and the mean square. So K is basically one of the terms that we are having and it is a number of different groups, right? Now moving towards the next point, we are having n of j here, okay? What is that? So that is the size, it is the size of the, it is the size of the jth group. So it is the size of the jth group. So whenever you see out a notation written like n and in the denominator j, so you could understand that, okay, this is the size of the jth group, right? Now let me come down to the next third point, and now here what we have s of j. Okay, we have the next value, the very next value, that is s of j. What is that actually meaning? So that means the sum of the values, it means the sum of the values in the jth group. So when we talk about n of j, so it means the size of the jth group, okay? And when we talk about s of j, so it means the sum of the values in the jth group. Fine. Next, moving towards the number 4. So number 4, we are having small n. What is that? So that is the total number of, it is the total number of all the values total number of all the values combined. Okay, so what is the small n? Small n is basically the total number of all the values combined. Fine. So even we could just as well say out it is a total sample size, that is sigma of n of j. Okay, right. Let's come down here. Next we are having number 5th, and that's the x, small x, that is equal to one value. Okay, one value, that is sigma, and here goes the x, that is equal to sigma, and here goes s of j. Okay, yes, this is what it is used for. So x is equal to one value, sigma x is equal to sigma s of j. Fine. Next we are having about the sum of, next we are having the sum of squares of all values, sum of squares of all values from, sum of squares of all values from every group combined. So yes, next we are having sum of squares of all values from every group combined, and what's that? That's sigma of, and here we go with the x square. So that's the sigma of x square, right? Now moving towards the point number 7. So next we are having that between group variability. So I will just write that as well. It's between group variability. So here goes the variability. It means what is that? It is the SS total. Okay, and what's the formula for that SS total? So the formula for that is sigma of x square minus, we have the sigma of sigma x whole square divided by n. Okay, 1 sec. Okay, that's a too much mess up right here, right? So let me just go down, get out some space for me to write out. Fine. So the formula which we are having for this particular is sigma x square, that sigma is x that sigma x square minus, in the bracket we have sigma x, into the bracket above we have a square, divided by n. Yes, now this is the formula which we have for the between group variability. Okay, sigma x square minus sigma x whole square divided by n. Okay, next we are having the number 8. So the number 8 we are having here, that is the total sum of squares. Total sum of squares, right? So onto this particular total sum of squares, so we have total sigma x square minus, we have sigma x whole square divided by n. Okay, so this is the total sum of formula for the total sum of squares which we are having here. Then now we have the explained variation, so it goes explained variation. Now that we have a sum of squares representing REPRESCN, like this, right? So sum of squares representing the variation among the different samples among the different samples, right? So that's completely the explained variation samples, and we could say that as SS between. SS, and downside we have like this between, and that is equal to SS between, that is equal to, let me get down from here so that I could get out of some space for writing. SS between, that is equal to, I would write it out here. So its sigma bracket goes on like this. So we have I would just write out Sj whole square divided by n of j, bracket closed like this, subtracted, then we have sigma s of j bracket whole square divided by n. Okay, so yeah, right, hope you are very much clear with this particular thing as well, whatever I had just written out at this particular place. Now fine, so explained variation already done. Whatever the unexplained variation? Okay, the number which I had mentioned above was number 9. Okay, right here. Okay, now it goes to number 10 here, that's the unexplained. It's the unexplained variation. Okay, it's the unexplained variation. Now, what is that actually unexplained variation? So it is a sum of squares. It is a sum of squares. It is a sum of squares representing. It is the sum of squares represent PR. Okay, that is REP representing. Okay, it is sum of squares representing variation. Representing variation within the samples. Representing variation within samples due to chance. Okay, so unexplained variation is basically the sum of squares representing variation within the samples due to chance. So what's the value for that? So it is SS width. Sorry, it's not width, it's within. 1 second. So it is SS within is equal to SS total and minus SS between. Right? So yeah, this is done. Now, right. So here we have many. We have some more things as well to be noted down. But right here, I'm just gonna stop about this particular place only for this particular video. So we had seen about the different ways for the calculation of sum of squares and the mean square. So these were the different ways that we have seen right here. Right. So hope you got out the idea very clearly regarding this particular thing, that how we will be able to do out all of these particular things. Right, so this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So now after studying these different types for the estimation, now I'll be taking you towards the next topic, to the further topic onto this particular only. Right, so I'm going to take out a different color here so that it separates between the previous and the new lectures. So here we go. So now I have some denotions here as well. So what we had studied, once again let me take the cursor right here. So what we have studied here, that it was variance between the samples, right? So variance between the samples, and one was variance within the samples. So whenever we just wrote this out, we write out in the form SS, and here in the denominator we write out here as between. So here it is SS and denominator is the between, right? So into that we have the sum of squares, the sum of squares that represents the sum of squares that represents PRESCNTS, right? So SS between is basically the sum of squares that represents the variation so here goes the variation among the different samples. So this is about this particular SS between, that the sum of the squares that represents the variation among the different samples, right? Now this was between, and next we were having one more, that was SS within, right? That we had studied as well. So now what was that? So let's go ahead with that particular thing once here. So that was the sum of, so it was the sum of squares that represent and that represents the variation. So here we have the variation. So SS within is basically the sum of squares that represents the variation within the samples, within the samples. Let me just get down out here and let me get out some space within the, right here we have. So that okay, the sum of squares that represents the variation within the, we have here the samples, SM, yeah, right, it's okay, samples that is due within the samples, that is due to chance, so here goes the chance. Great. So S is within. So this is basically the sum of squares that represents the variation within the samples, and that so is basically due to chance, right? Now what do we basically, to find out the sum of a square, what do we meant from this particular word that I was saying in the starting, the sum of the squares, this one which I had used out in here as well, this particular one, right? So what does this actually means out? So this actually means that to add together squared quantities, now which basically in some cases may be weighted, right? In some of the cases it may be weighted. So to add together both, so add on those squared quantities together, right? This is what this particular term is. Okay, now basically why we just use out the sum of squares. So we use out the sum of squares to calculate out the sample variance, and basically for calculating out the standard deviation. Now where it is used completely, it is used in the descriptive statistics. So in the descriptive statistics, the sum of squares is used to calculate out the sample variance and to calculate out the sample standard deviation, right? So hope I am very much clear with both of these things to you, that basically what are these means and what are the things that we have out here. Now next we are having some more things to go ahead here, so I would just start writing those things. I would just not dictate that out. So right here we go. So now we have one another term, that is MS, capital M, that capital S. Now what does that actually means? So MS means the mean square. So it's the mean, and here it is the square. Okay, so MS means the mean square. Now what is that MS between? So I would just write out that thing as well. So MS between, one second. So here it goes up between in the denominator, right? So MS between is the variance. MS between is the variance. So here goes the variance between, MS between is the variance between groups, and MS within, and MS here goes the within. So MS between is the variance between groups, and MS within is the variance between the, sorry, not between, it's the variance within the, because between is almost finished up, right, because we discussed it above. So here goes, and is MS within is the variance within the groups, right? So that was the about the MS mean, that was the mean square, right? So MS between is the variance which is between the groups, and when I talk about MS within, so MS within is the variance that is within the group. So both are different things, right? So when I talk about that some variance is between the groups, so that is another one. And when I talk about that some variance is within the groups, so that's again a different thing, right? So this is about the MS means, that is the mean square. Let me take you to above a little bit once. Right here, 1 second. Great. So SS basically was the denotation that we used, right? We used SS between, that was the sum of the squares that represented out the variation among the different samples, right? We just did out this particular thing, that was one of the sum of the squares. So SS basically means the sum of the squares, okay? Now what do this SS between represent? So it represents out the variation among the different samples. When I talk about, except this between, when I talk about the within, so what about the within? So SS within is basically the sum of squares that represents out the variation within the samples that is due to chance. So in SS within, the sum of squares which appear out that represent out the variation within the samples, and that is due to chance. What is the meaning of MS right here? So MS means the mean square. Okay, what is the meaning of MS? MS means the mean square. So MS between is the variance between groups, and MS within is the variance within the groups, right? Yeah. So hope I am very much clear with the like definition and with the part for this both of these, that what are these SS and what are these MS, how to categorize under, how to categorize them between within and the between of both of these functions. What are these completely meant? What is the meaning of sum of squares? What is the mean of squares? And I hope all of these things are very much clear to you. Now what are we left with? Now we'll be doing out and studying out that how we do the calculation for the sum of squares and the mean square. That we will be going ahead in the next video. Right, so hope you got out all the things very clear in a very clear way regarding whatever I just told you right here. So we'll see you in the next video. So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So we were learning about the different terminologies in the probability, right? So further what I will be taking you through is that I'll be taking you through calculating of the probability of an event where all the outcomes in the sample space are equally likely. If you remember, and if you did have watched up my previous video, so on to that, the last topic which we discussed was equally likely, right? We were dealing with that. What is this equally likely actually, right? And further, I'll be taking up today's video from this respective topic only. So equally likely means that each outcome of an experiment occurs up with an equal probability. Okay, that each outcome of an experiment occurs up with the equal probability. This is what equally likely actually meant out. Okay, now if I have to compute up the probability for that, so how will I be doing? So let's check that out here. So let me put that out. So oh, I am so sorry, let me just take the thin pen. Fine here. So it is to calculate the probability, probability, B-I-L-I-T-Y, okay? So to calculate the probability of an event of an event A. Let's say that my event is actually A, okay? So for calculating up the probability of an event A, when all outcomes in the sample space, are equally likely. Okay, when all the outcomes in the sample space are equally likely. Okay, are equally likely to count the number of outcomes for event A and divide by the total number of outcomes, and divide by the total number of outcomes in the sample space, okay, pretty fine. So to calculate up the probability of an event A where all the outcomes in the sample space are equally likely, to count the number of outcomes for event A and divide by the total number of outcomes in the sample space. Okay. So, onto that respective case, this is how you calculate out the probability of an event. Okay, when the outcomes in the sample space are equally likely. Okay, now let me just quickly take up an example here. So, let me just get down from this particular place. Fine. So, my example goes in a way that, let's say, if you, so if you toss a fair dime and a fair nickel, okay, if you toss up a fair dime and a fair nickel, the sample space, or you can say a coin, okay, so the sample space is, what's my sample space? So that will be head head, comma tail head, comma head tail, comma tail tail, right? This is the sample space if you toss up the coins, right? This is the sample space which occurs about. Now, into this case, this will be a sample space if you like toss two coins simultaneously. So this will be sample space, right? Now, where into this question only, where T is my tails, where T is equal to tails, and H is equal to heads. Okay, where T is equal to tails and H is equal to heads. Okay. Now into this respective case, so the sample space is having four outcomes, right? In this, right, we are having the sample space. The sample space has four outcomes. Okay, the sample space has four outcomes. So what will be my A? Right, the way to just check above that, if you toss a fair dime and a fair nickel, the sample space is head tail, head tail, and tail tail, right? Where T refers to my tails and H refers to my heads. Right, so the sample space has this respective sample, the space is having a four outcomes in total, right? So, further, I'll be having up there that the A, that's my probability. So it's equal to getting one hit. So I have to compute up the probability for getting up the one hit. So there are in total two outcomes which are having hits, right? Which are having one hit. There are in total two outcomes. So I would write that there are two outcomes. There are two outcomes. First is my head tail and second is my tail head. These are my two outcomes, right? So into that case, I'm going to write up that the probability of A is equal to 2 by 4 because in total we were having 4 outcomes, and from that 4 outcomes we were having 2 outcomes which are having one head. Okay, so for that we were having these 2 outcomes, so head tail and tail head. So in total I have the 2 by 4. So 1 second, yeah, here it is. So 2 by 4, it's equal to 1 by 2 and that's equal to 0.5. And remember I told in my previous video that the probability, if the probability of A is equal to 0.5. So into that case, we say that the event is equally likely to occur or not to occur. If you remember, let me just take to you at that particular position. Yeah, so here I told in the previous video that if the probability of A is equal to 0.5, it means the event A is equally likely to occur or not to occur. And see here what I am getting probability of A is equal to 0.5. Right, so this is how you calculate up the probability of an event for all the outcomes in the sample space which are equally likely. Okay, so hope I'm pretty much clear with this particular thing too. Great. Fine, pretty fine. Now this is how you approach up the questions into the suspective manner. Simply whatever the question was given, I was given that this die has been rolled. So two simultaneous die have been rolled. So I simply put up the things for those only. Further, we have to write up all the sample spaces which occurred or which will be occurring. So it was head tail, tail head, and tail tail. Right, these are the only 4 outcomes which could occur if the coin is tossed. For the T was referring to my tails and H was referring to my heads. Right, so into that case, the sample space will actually have the 4 outcomes, right? And A will be that getting 1 head. So in that case, there will be now 2 outcomes. Right, that is head tail and tail head, because these are the only 2 outcomes in which head is occurring. One head is occurring, right? These 2 are the only events. So I just wrote up both of those, and then the probability of A is 2 by 4, that is equal to, if I cancel that out, so it's equal to 1 by 2. Further I have 0.5 and the probability of A is 0.5, so that means that it is likely actually to occur, right? It is equally likely to happen, right? So this was what we just discussed about as well. Right, so hope I am pretty much clear with this particular thing to you regards of this respective example which I did have taken up here. Right, now what I want to do is that I want to just revise up these terminologies once for you, because it will be very much easier for you to relate up with the things and to get up the things here. Okay, so we started up here that what's up an experiment. Right, so what is that? It is a planned operation which is carried out under the controlled conditions. Okay, if a result is not predetermined, so then we see that the experiment is said to be a chance experiment. Okay, if the result is not predetermined, so in that case we say that the experiment is said to be a chance experiment. Okay, what we meant out by outcome, so that is the result of an experiment. Okay, the result of an experiment is called an outcome. Fine. What is a sample space? So a sample space is a set of all possible outcomes. So whatever the possible outcomes are there, so it is a set of all of the possible outcomes, sample space, right? And how you denote that out? So that is denoted using the capital S. So capital S is used to denote the sample space. Okay, right. Yes, further we discussed about the event, that what is an event. So an event is a combination of the outcomes, right? So A and B represent the events, that is probability of A. If you want to write that in the form of probability as well, so it is probability of A like this. So what are the uppercase characters you are having? Those all represents up the events for you, right? Now, the probability of an outcome is a long-term relative frequency of that outcome, right? Now, if the probability of A is 0, is equal to 0, it means that the event can never happen up. Okay, if the probability of A is equal to 1, so it means that the event A always happen. And if the probability of E is equal to 0.5, so it means that the event E is equally likely to occur or not to occur. Fine, so equally likely means that each outcome of an experiment occurs with equal probability. Okay, so to calculate the probability of an event A when all outcomes in the sample space are equally likely to count the number of outcomes for event A and divide by the total number of outcomes in that respective sample space, right? And for that, we just took away, see up an example that how do we compute the probability of an event when the outcomes in the sample space are equally likely. Right, so hope I am pretty much clear with this particular question to you, that how to solve a problem. That was a quick, very easy problem. I hope that's pretty much clear. Further, we'll be having some difficult problems as well to solve about and to look at how to deal with some multiple type of problems, some difficult problems, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So as in the previous video we had discussed regarding the test of two variances, that what is this test of two variances and basically what are the things we do and what we basically do not do, all of the things we have discussed out. Now let's quickly take out a very general example. I'm just not going to solve out anything or anything like that. It's a very general example that I'm going to take out, okay? So I would just simply change out a color, then I would proceed on with the writing. Great. Okay, so here goes that suppose we sample randomly from two independent normal populations, fine. So suppose we sample randomly from two independent normal populations. Okay. Now in that case, what we are having, the things that we need to be put on here, I need to be remember out as well. Okay, dot. Fine. Now here we have let sigma 1 square and okay, and here we have sigma 2 square. So sigma 1 square and sigma 2 squares, these let be the population variances, and S1 square, comma, okay, be the population variances and okay, this is S1. One second, let me write down 1 very clearly. 1. Okay, S1 square multiplied by, not multiply, here will go the and. Let me just get down here. So suppose we sample randomly from two independent normal populations. Let sigma 1 square and sigma 2 square be the population variances, and S1 and S2 squares be the sample variance fine. So one second, right here. So let these are sigma 1 square, sigma 2 square be the population variances, and S1 square and S2 squares be the sample variance, right? So in that case, now basically what is gonna happen? Full stop. Let the sample sizes be the population variances. Okay, let the sample sizes, that I have already done that. Let the sample sizes be the, okay, not population, it's that another one. Let be the N1 and N2. So N1 and N2 are basically the sample sizes which we have here. Okay, N1 and N2. Fine. Next, since we are interested, next is basically right here. Now, let's say we are interested in comparing the two sample variables we use for the F ratio. So in that particular case, yes, of course, we could use out this particular type of like you could use this particular type of question or answer this out in this particular way and address all of the things, right? Fine. So basically, as we just wanted to find out and we're interested in comparing the two sample variances. So in that case, we're going to use out the F ratio that's formula. Okay, let me just come down and show you that F ratio 1. So here it goes that F is equal to, then okay, now we are having N1 and S1 and S2. It goes S1 upon S2 whole square right here, okay, just like this. After that we have this, then we have the second one as well. Okay, so into that particular case I'll be mentioning out here S2. Okay, S2 in the bracket we have S2 square divided by and that is completely sigma 2. Right, sigma, okay, 1 second. And here it's sigma down wala na, right? So here sigma 2, fine. So if this is the particular formula that we have out here, S1 upon, okay, that's S1 upon sigma 1 and S2 upon sigma 2. So let me now just clear out the complete formula and write that out again. So here we go on to the draw and I will just run all of the things whatever we have written till now. Into that case this draw comes here and I will just put on the different things. Let's put on the formula first of all, fine. So F is equal to, I have this one particular block, okay, and onto that particular block we have S1 square upon, okay, 1 second. S1 square and here we have V1 square upon, we have S2 square, okay, we have S2 square and then down the line, down this particular one, we have sigma 2 whole square, right? So yes, this is how we just put on the things, we just put on the relevant formula. So after this basically, what is this F having? So F has the distribution, here goes the F has the distribution that is capital F approximately equal to, this is capital F, and into the bracket you have n1 minus 1 comma n2 minus 1, okay, where now into this case n1 minus 1 are the degrees are the, okay, let me remove that out, n minus 1 are the degrees of freedom okay, degrees of freedom for the numerator and n2 minus 1 numerator and n2 minus 1 are the degrees of freedom for the denominator, fine, are the basic degrees of freedom for the denominator, right? So yeah, hope I am very much clear with all of those things whichever I have mentioned out. So let me give you again an idea. So we have taken on an example that suppose we sample randomly from two independent normal populations, right? So let sigma 1 square and sigma 2 squares be the population variances and S1 square and S2 squares be the sample variance. Let the sample sizes be N1 and N2. So F is equal to S1 square upon V1 square upon S2 square upon sigma 2 squared. Fine. So it has a distribution F belongs to F, that is in the afterwards, which is on the right hand side F. Inside that we have N1 minus 1 comma N2 minus 1 ke pure, like they have Then we have n1 minus 1 are degrees of freedom for the numerator and n2 minus 1 are degrees of freedom for the denominator. Right, so hope I am very much clear with whatever I just referred regarding the F distribution. So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So today we'll be understanding about some important characteristics of probability experiments. Okay, we'll be understanding about some important characteristics of the probability events, right? So let's get started out here. Let me just quickly change up a color here. And then for sure we can proceed up at this particular place, right? Okay, I'll be start writing up here and we'll be seeing further what are the important characteristics of the probability experiments. Actually, there are some law that you have to understand. Okay, fine. So the important characteristic ISTIC. Okay, yeah, the important characteristic of probability of BILITY. Okay, so the important characteristic of probability experiments is known as the law of large numbers. As a law of large numbers. Now, this respective law of large numbers, what it is about, that I'll be talking about right here. But you have to understand this particular thing, that there are some important characteristics of probability experiments, okay? And that are known as the law of the large numbers. This is a term which we use up here, the law of the large numbers, okay? Now, further I'll be taking up that what are these respective law of large numbers, okay? Now let's start up here that as the number of repetitions, repetitions, okay. So as the number of repetitions of an experiment is increased, let me just get down. Law of large numbers says that as the number of repetitions of an experiment is increased, I'm just interpreting like that, okay? So as the number of repetitions of an experiment is increased, the relative frequency, so here comes my frequency. So the relative frequency obtained in the experiment tends to become closer and closer, comes to become closer, closer, and tends to become closer and closer to the theoretical probability. Okay, probability. So the law of large numbers says that as the number of repetitions of an experiment is increased, like as we see of an increase in the number of repetitions of an experiment, the relative frequency which you have actually obtained in the experiment, that becomes closer and closer to the theoretical probability. The relative frequency which is obtained in the experiment, that slowly and slowly comes closer to the theoretical probability which you have. Okay, even though now there is something more as well, not only this is the law, but there are some more things in this. So even though the outcomes do not happen according do not happen according to any set, according to any set pattern, or order, or according to any set pattern or order, overall, the long-term observed, the long-term observed relative frequency, the long-term observed relative frequency, which we did right above, we just got that out. So the long-term observed relative frequency that yes, so the long-term observed relative frequency will approach the theoretical probability. The theoretical probability, and I'm just simply writing up the short form for the probability like this. Okay, the theoretical probability. Fine. So this is the law of large numbers, which we do actually have up here. Let me just hold on the cursor onto my hand, then I could just move forward. This is the law of large numbers. Okay, what does it say? It says that as the number of repetitions of an experiment increases, the relative frequency which is obtained, okay, the relative frequency which is obtained in the experiment, that tends to become closer and closer to the theoretical probability. Okay, now even though the outcomes do not happen according to any set pattern or order, okay, even though the outcomes do not happen according to any set of pattern or order, overall the long-term observed relative frequency will approach the theoretical probability. So law of large numbers says that whatever the relative frequency of an experiment is there, that tends to become slowly closer to the theoretical probability. It doesn't matter that according to any set or pattern or anything like that, but yeah, the relative frequency will approach closer and closer to the theoretical probability. This is what the law of large numbers actually say here, and that's one of the very important characteristic of a probability experiment that is to be known, and not only known but that is as well to be kept up into the mind. Okay, now when do we use up a word that is empirical? Okay, the word empirical is often used instead of the word observed. So at some time if I used about observed, or at some point if I use about empirical, so do not get confused in that. Observed and empirical are the same things only. Okay, if I write empirical or if I write observed, the meaning would be the absolutely same only, because it could happen that sometimes if I go in the more technical terms, so if I could write up empirical. Right here I didn't have use, I simply used up the long-term observed relative, but instead of that I could simply use up long-term empirical relative frequency. Okay, so empirical is only used instead of observed only. Okay, do not get just confused out onto that particular things which are mentioned up here. Right. So the relative frequency which you have up into your experiment, that will approach closer and closer slowly to the theoretical probability, and that is observed actually. Okay, the long term observed means the long term empirical relative frequency will slowly and gradually approach to the theoretical probability. This is what is the law of the large numbers. That is what actually it says. Right. Great. So yeah, hope I'm pretty much clear with this particular thing to you regarding the law of large numbers. That what do you have up here, and what is this law of large numbers actually mentioned up here, right? Hope I am pretty much clear with this particular thing to you. Okay. Now further we'll be having different types of events. We have the OR event, we have the AND event. We'll be moving and looking about those events into the further videos. So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So Our today's topic of discussion is independent events. Okay, so we'll be learning about that. What are the independent events and what are the different sort of things in the independent events and each and everything, right? So, right, let me quickly put up the topic for today, and that's independent. And here goes the events. Great. Okay, so we have some further conditions here that are to be put it upon. Okay, and if those respective conditions are true, then first of all, in that case, we say that these are the independent events. Okay, if those respective conditions are true. Okay. So in this case, I would simply mention it up here that two events are independent, are independent. Two events are independent if if the if the following are true. Okay, so two events are independent if the following are true. Let me get down right here. Okay, so the very first condition is that if these are true if probability of A or B. Okay, if the probability of A or B is the probability of A. Okay, this is the very first condition that has to be satisfied out if you are checking out for that respective events are independent or not. Okay, next, my second condition goes that the probability of B or A, and that shall be equal to the probability of B. Now that is my second condition, which actually has to be satisfied out, like any of the ones you could choose out, whichever is satisfying. Now goes my third condition that the probability of A and B probability of A and B is equal to probability of A dot probability of B. Okay, so right here we have this respective thing that the probability of A or B is equal to probability of A, probability of B or A is equal to probability of B, and probability of P and B is equal to probability of A dot probability of B. Okay, so now if these following are the true, okay, the conditions mentioned up here, if the conditions are true, then into that respective case, we say that the two events are independent. Now, we have some more things regarding the independent events that are to be seen and even that are to be learned about. Let's move for those respective things. Here I would start writing up the things. So, the two events A and B are two events A and B are independent if the knowledge that one occurred does not affect the chance of other occurs. Now, what do I mean up here from whatever the things I did have written up? So listen to me, that two events C and B, those respective events are independent if the knowledge that one occurred does not affect the change of other occurs. It means that whatever the knowledge that one has occurred does not affect the chance of other occurs. In that case, A and B, the two events are said to be independent, right? So this is what this independent here means. Now, Okay, let's take a very quick example for this independence thing, for checking out the independence event. So let's say that the outcome of the two roles of a fair okay, let me just write that only, because it would be very much more clear while writing out the thing. So let's take up an example that the outcome of two roles of a fair die, the outcome of two roles of a fair die are are independent events. Okay, let's say, for example, we took that the outcome of two roles of a fair die are independent events. Okay, so the outcome of the outcome of the first role does not change the probability. I am simply writing this that is actually referring to my probability only. Okay, make sure remember that out. So the outcome of the first role does not change the probability for the outcome of the second role. So the outcome of the first role does not change the probability for the outcome of the second role. Okay, so in this case, to show that the events are independent, to show that the events are let me just quickly get down here. To show that the events are independent, to show that the events are independent, you must show only one of the above conditions, and here, okay, one second, above here goes the conditions. So to show that the events are independent, you must show only one of the above conditions. So if the two events are not dependent, then we say that they are dependent. Okay, so here goes, I would just write that out, that if two events are not dependent, then we say that the events are dependent. Okay, so in that case, that if the two events are not dependent, so in that respective case we say that the events are dependent. Now the sampling which we have out here, so that respective sampling can be done in two ways, that is with replacement or without replacement. So these are the two methods with the help of which this respective sampling could be done out. The first one is with replacement, and the second one is the without replacement. Okay, so with that, with and without replacement, we'll be seeing both of the things in detail in the next video, not right up here. Okay, so today we discussed about a little about the independent event. So whether if the following conditions, which are these three mentioned up here, if those are true, in that case we say that these respective two events are independent. Okay, and the two events A and B are independent if the knowledge that one occurred does not affect out the chance of the other occurs. So in that case we say that these two events are independent, right? And we just saw up a quick example here that how do we do up the respective things. Great. So, hope I'm very much clear with these things that what are the independent events, what are the certain conditions that are to be followed up here, and what are the certain conditions that are to be satisfied and set as true for making up the event as the independent event. Right, we'll be continuing this up into the next video. So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So right away in the previous video, we discussed about the independent events. That what are the independent events? So there I told you about the sampling, that we have two ways for the sampling. That is first of all, that is with replacement, and the second one is the without replacement. So right in today's video, we will be dealing and checking about the with replacement and the without replacement. So here goes my very first one, and first we will be discussing about the with replacement. Okay, so with replacement. So now here goes my conditions and my respective things that are to be taken care of. 1 second. This one is the one, and let me just quickly take out my color. Great. So let's learn about first of all the with replacement thing. Now, in the with replacement, what happens that if each member of a population is replaced after it is picked, then that member has the possibility, BILITY, then that member has the possibility of being chosen more than one. So if each member of a population is replaced after it is picked, then that member has the possibility of being chosen more than once. Okay, so when the sampling is done, when the sampling is done, just let me get down here and get out some space for writing. So when the sampling is done with replacement, 1 second, oh I'm so sorry, is done with, here goes the replacement. So when the sampling is done with the replacement, then events are considered to be independent. 1 second, then the events are considered to be independent, meaning the result of the first pick will not change the probabilities. 1 second, BILI. Okay, then if the sampling is done with replacements, then events are considered to be independent, meaning the result of the first pick will not change the probabilities for the second pick. Okay, so this is what actually happens up here in the 1 second. Let me hold on the cursor right here. In the with replacement, that if each member of a population is replaced after it is picked, then that member has the possibility of being chosen more than once. When the sampling is done with replacement, then events are considered to be independent, meaning the result of the first pick will not change the probabilities for the second pick. Okay, so this is what happens in the with replacement, sampling with replacement. This is what happens. Now, if I next talk about the second one, just let me quickly hold on a color here, the one which we did previously as well. Now, second one goes here, and that so is the without replacement. So without, and here goes my replacement. Now let's learn under that what comes under this without replacement. Let me took on the same color once very quickly. Great. Now here goes that when sampling is done when sampling is done without replacement, when sampling is done without replacement, and here goes replacement. When sampling is done without replacement, then each member then each member then each member of a population may be chosen only once. So when sampling is done without the replacement, then each member of a population may be chosen only once. Now in this case, the probabilities over here goes the probabilities, billities. So in this case, the probabilities for the second pick, the probabilities in this case, the probabilities for the second pick are affected. The probabilities for the second pick are affected by the result of the first pick. So in this case, the probabilities for the second pick are affected by the results of the first pick, and the events are considered to be dependent or not independent. So here what happens in this, that is in the without replacement, that when sampling is done without replacement, then each member of the population may be chosen only once. Okay, so in this case, the probabilities for the second pick are affected by the result of the first pick. The events are as well considered to be dependent and not independent. Okay. Right, so this is what was about this particular thing, that is for the sampling we were having two things, right, with replacement and without replacement. So let's once again took a clear idea that what happens in both of these. So when I talk about the with replacement, so if each member of a population is replaced after it is picked, then that member has the possibility of being chosen more than once. So when the sampling is done with the replacement, then events are considered to be independent. It means that the result of the first pick will not change the probabilities for the second pick. Second is without replacement. So when sampling is done without replacement, then each member of a population may be chosen only once. So in this case, the probabilities for the second pick are affected by the result of the first pick. So the events are considered to be dependent or not independent. right? And this is what where we completed out our independent event. So these were the things which were there up here in the independent events. We did already saw about this, that the two events are said to be independent if the conditions mentioned up here are true. So the probability of A or B is equal to probability of A, probability of B or A is equal to probability of B, or the probability of A and B is equal to probability of A dot probability of B. So these are the conditions that are to be taken care of, and even that are to be satisfied up here for the independent events. Right, so hope I'm clear with this particular things to you, that where we see that the events are independent, and for the sampling as well, we have two techniques. First one is with replacement and second one is the without replacement. Hope I'm very much clear with that. So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So into the previous video we discussed about different terminologies and we discussed about some rules. Right, now I'll be taking you through different types of events which we have up here. Okay, I'll be dealing up with different types of events which we have up here. But before that, let me just quickly let you know that what event actually is, because we did cover this onto our previous videos only. But yeah, let me give you a quick idea. So what's an event? So an event is any of the combination of the outcomes. Whatever the outcomes are there, so a combination of all those outcomes forms up an event. Okay, how do we denote out? So events are always denoted using the uppercase characters. Okay, and if you have to denote up the probability of any event, so you write up P probability and into the bracket you write up that respective event. Okay, this is the denotion regarding the events. So further now we'll be discussing about the different events and the formulas with quick examples. Okay, so let me just quickly take up a new color here so that we can proceed on with the writing up of the things. Pretty fine. Let me start out here with the OR event. Okay, my very first event is the OR event. Fine enough. So now what is an OR event? So into that what happens? So an outcome into OR event, an outcome is in the form of A or B. This is how we just write that out. Okay, A or B. Okay, A or B. If the outcome A or B, if the outcome is in A or is in B. Okay, if the outcome is in A or is in B. Fine, let's say if I took up a quick example here regarding this OR event. So I could say an example that let's say you are having up an event that is A, and let's say that's 1, 2, 3, 4 and 5. Okay, let's say this is an event. Okay, and what about B? So B is equal to, you have here 4, 5, 6, 7, 8. Okay, this is B. Let's say whatever you are having. Now if I have to write up A or B, okay, if I have to write A or B, first of all listen to me very clearly that this is the denotion how you write up A or B. Okay, so if you have to mention up A or B, so whatever the numbers you're having up into A and B, you will mention up all of those events. And if a number is occurring both the times in both of A and B events, you'll be writing up that respective number only once. Okay, what are the outcomes you're having? So if that outcome is occurring in the event A as well, you're having that outcome, and in the event B as well, if you're having up that outcome, so it will be written only once into the final answer. So it will be in a form that 1, 2, 3, 4, 5, 6, 7, 8. Okay, this will how B or A or B will be there actually. Okay, now here 4 and 5 are not listed twice because we are calculating A or B. Okay, so within A or B we are calculating, and if you use up this OR event, so into that if you have any repetitive numbers, those repetitive numbers gets converted only one time. It's not that case that you'll be writing these numbers 2 times. No, if a number is coming repeatedly, so you'll be writing up that only 1 time only. No matters it is coming 2 times, 3 times, 4 times, 5 times, whatever it is. Okay. So hope I'm pretty much clear with this particular thing about that outcome. Okay, so if you write up an outcome in the form of A or B, so in that case the outcome is in A or is in B. Fine, so hope I am pretty much clear with this example to you of the OR event. Next type of event which I will be having is my AND event. So it's and here is my event. Now what does actually happens upon in the AND event? So here the outcome is the event, and outcome is the event A and B, and outcome is the event A and B if the outcome is in both A and B, if the outcome is in both A and B at the same time. Okay, so an outcome is the event A and B if the outcome is in both A and B at the same time. Now, what example for that we can have? So let me just get down some space out for me right here. So the example for A and B could be that let's say I'm having A event as, let's say, 1, 2, 3, 4 and 5. Okay, let's say this is my A event, and what about my B? So let's say my B event is 4, 5, 6, 7, 8. Okay, so now into this, if I have to write A and B, A, and here goes and this is B, if I have to write that out. So how will I be writing? I'll be writing whatever the common numbers I am having upon to both of the lists, whatever the common outcomes I am having in both of the events, I'll be writing those. So the common events which common outcomes which I'm having is 4 and 5, right? So I did mention 4 and 5 in the A and B. So this is how you find out the this is how you use the AND event. Okay, whenever you have to find out the AND event, so whatever the common outcomes you're having in both of the events, that common event will be your answer. Okay, so always remember, please do not get confused between the OR event and between the AND event, because these are actually a slight difference only. In the OR event, whatever the repetitive numbers are there, we do not consider those repetitive numbers. Okay, and in the AND event, if a number is repeatedly coming, so we just put up that repeatedly number only. Fine, so hope I'm pretty much clear with these both of the things now. Okay, now let's discuss about the complement of event A. Okay, let's discuss about the complement. So the complement of event A is denoted. The complement of event A is denoted by A dash. Okay, this is how you denote up the complement of an event. So the complement of event A is denoted by A dash. Okay, so you could simply write that A dash, or you could read it as A prime as well. Okay, that's your choice. Where there are different ways for speaking that out: A complement or A dash or A prime, whatever you just wish out. Okay, so I would say A prime. So A prime consists of all outcomes that are not in A. Okay, so this actually A prime consists of all of the outcomes that are not in A. Okay, so further let's say if I took up an example in the similar manner. So if I have to write the probability of A plus probability of A prime, okay, so that will be equal to 1. This is one thing which we have up here, okay, probability of A plus probability of A prime is equal to 1. Now if I took up an example here, so my example, let's say it goes that my example is, let's say I'm having up a sample space, and that is 1, 2, 3, 1, 2, 3, 4, 5, and 6. Let's say this is my sample space, okay? And let A is equal to, 1, 2, 3, and then 4. Okay, let A is equal to 1, 2, 3, and then 4. Then into that case, A prime. Okay, A prime will be equal to 5, comma 6. Okay, into that case, A prime will be equal to 5, comma 6. Right? So because 5, comma 6 is the term which is not occurring in both of these. Okay, into that, this 5, comma 6 will be my A prime, my complement of A. And now if I have to find out the probability of A, okay, so my probability of A will be 4 by 6, right? 4 by 6, because in total we are having in the total sample space you're having 6 numbers, and for the A you are having 4, so it's 4 by 6, right? And if I have to talk about the probability of A prime, okay, the probability of A prime will be 2 by 6. Okay, the probability of A will be 2 by 6. How come 2 by 6? So because here in the probability in the A prime we are having only 2 numbers, but my real sample space is having in total 6 numbers. So my A prime and here my sample space, which will be 2 by 6. Now if I do the addition for both of those, like probability of A plus probability of A prime is equal to 1, into that if I apply 4 by 6 plus 2 by 6, if I verify this out, so let me just get down. So here you will be having up 6 by 6 is equal to 1. So into that respective case, 1 is equal to 1. So into that case, we actually did verify that the probability of A plus probability of A prime is equal to 1. Right? So hope I am pretty much clear with this particular thing to you regarding the OR event, the AND event, and the complement of event A. Okay, how to find out the complement. Then what about the OR events, and then how are the AND events as well executed? How do these things actually work, and how do you calculate out the OR AND events and the complements? Right, hope I am pretty much clear with this particular thing to you. Right, so further we'll be learning about the conditional probability onto the next video. So this is all for this video. Till then, thank you and take care.